Greetings again everyone. How to solve x in this situation where we have 2 to the power of x plus x is equal to 5. Now I want to share with you that normal algebraic methods cannot be used to solve these types of equations. If you like, you can pause this video at any time and try to work this one out by yourself. You may also check out my Math Olympiad playlist to see how to solve other algebraic exponential equations like these ones. Now you may want to save this video for future reference, so you can smash that like button and subscribe to my channel to see more of my videos on these types of equations. Now looking at our equation, we can approximate the value of x by randomly selecting some numbers. By doing this, we can see that x is equal to 1 point something. Now moving on to solving our equation, I did say that we cannot solve this equation by using normal algebraic methods. So what I'm going to do here is just to introduce the type of method that we're going to be using to solve this equation. And it is by using the Lambert W function. Now this method is used to solve equation where the variable is in the base and also in the exponent. How this works is that if we have an expression such as a times e to the power of a, if we were to take this expression and apply what we call a w function to this expression, so we can put it in brackets and we apply a w function to this expression, the result is a. So what this means is that our equation here, if we can write our equation in the form of a times e to the power of a, then we can apply this w function to this equation. We start by subtracting x on both sides of this equation, so that 2 to the power of x is equal to negative x plus 5. And then from here we divide both sides of this equation by 2 to the power of x. So 2 to the power of x over 2 to the power of x is just one whole, so we're just going to have that equal to 1. So this means that we can write our equation as 1 is equal to negative x plus 5 over 2 to the power of x. Now this 2 to the power of x is 1 over 2 to the power of x, which means applying our laws of indices here where we have 1 over a is the same as saying a to the power of negative 1. We can write 2 to the power of x in this form. So we take 2 to the power of x and we write it in this form. So here we have 1, so 1 is equal to negative x plus 5. We also can put this in brackets. And then we say times 2 to the power of this 2 to the power of x, right, again in this form. So that's times 2 to the power of negative x. As we are writing our equation in the form of a times e to the power of a, when we look here, we see we have a negative x and we also have negative x in the power. But here we have a plus 5 here and we also need that plus 5 in the power. How do we get it here? We can multiply this by 2 to the power of something. Now how this works is in what we call the law of indices, where we have a to the power of m plus n is the same as saying a to the power of m times a to the power of n. So we can rewrite our equation applying this power rule here, where we have m plus n, so negative x plus 5. The key here is having the same base, 2 and 2 here, as a times a here. The next, we have the m. We can have this as n would be the plus 5 and the m would be the negative x. So this means that we have 2 to the power of plus 5 or positive 5. And what we're essentially doing is that we're multiplying both sides by 2 to the power of 5. So we're just going to have 2 to the power of 5 also on the left hand side of this equation. So from here we're just going to rewrite what we have here. And we know that 2 to the power of 5 is 32. And 32 times 1 is just going to give us 32. So this means that we have 32 is equal to negative x plus 5 times 2 to the power of negative x. And the fact that we're multiplying by 2 to the power of 5, we can simply add the powers, so we'd have negative x plus 5. Now let's look at what we have here. We have negative x plus 5 and in the power we have the same thing, so we have a here and we also have this a. But what we don't have is the e, so we need to write 2 in the form of e. So we can replace this 2 with e. Now writing 2 in the form of e, we can have 2 being written as e to the power of ln of 2. Now how this works is that ln means natural log, where the base is e. So having e raised to the power of ln, the ln will cancel out with the e and what's going to be left is just the 2. So then we can rewrite our equation So we say 32 is equal to negative x plus 5, and we put that in brackets, times e. So we're writing 2 in the form of e, so we have e ln of 2 in brackets raised to the power of negative x plus 5. So what we basically have here is that we have 32 equals negative x plus 5, and that's going to be in brackets. We just always keep that in brackets for now, times e to the power of ln of 2, and ln of 2 is multiplying negative x plus 5. Now here we have ln of 2 multiplying negative x plus 5, but here we only have negative x plus 5. We need to also multiply this by ln of 2. So from here we have 32 is equal to negative x plus 5 in brackets times e to the power of ln of 2 in brackets negative x plus 5. So in order to have this ln of 2 here, we can multiply both sides of this equation by ln of 2. So this means that we have ln of 2 times 32 is equal to, we can have this ln of 2 here, we can just drag it right here because we're just multiplying this expression. So we can start by saying ln of 2 times negative x plus 5 times e to the power of ln of 2 in brackets negative x plus 5. So here we have ln of 2 in brackets negative x plus 5 times e to the power of ln of 2 in brackets negative x plus 5. So we have our e in the middle, so we have a times e to the power of a. So what we're saying with the Lambert W function, if we were to add a W function to this expression, the result is a. So if we were to bracket this expression and add a W function, and we would apply this function to both sides of this equation, so we'd have w in brackets ln of 2 times 32 as well. If you like this video so far, you can give me a thumbs up. If you also would like to see more videos on the Lambert W function, you can also subscribe to my channel. So from here we'd have w of ln of 2 times 32 is equal to, and as we said, w in this function gives us the value of a. So the value of a is ln of 2 in brackets negative x plus 5. So we have w of in brackets ln of 2 times 32 is equal to the value of a, which is ln of 2 in brackets negative x plus 5. And then from here we solve x by dividing both sides of this equation by ln of 2. So we then have w of ln of 2 times 32 all over ln of 2 is equal to, on the right ln of 2 will be cancelled out, so that's equal to negative x plus 5. And then we can go ahead and subtract both sides by negative 5, hence cancelling our 5 here. So on the left we would have negative 5 plus w of ln of 2 times 32 all over ln of 2. And as we said that these 5's will be cancelled out. Now from here we find the value of negative 5 plus w of ln of 2 times 32 over ln of 2. And we can use Wolfram Alpha, this calculating tool, to give us that value. So here we have that value in our calculator. Let us see what it outputs. So we can see here that this is approximately equal to negative 1.7156, and that's a lot of recurring decimals there. So we can just round this off to about 3 decimal places, so we can have negative 1.716. So we have negative 1.716 is equal to negative x. And now from here we solve x by dividing both sides of this equation by negative 1, just to remove that negative from the x. So we then know that x therefore is equal to 1.716. And this is our solution for x in this equation. Now what we can do from here is that we can verify this solution of x. So our equation states that 2 to the power of x, we know what x is, but we're just going to write out our original equation. So we have 2 to the power of x plus x is equal to 5. Now we did estimate that x would have been equal to 1 point something. And now in our workout we do have a value of x which is also equal to 1 point something. So we have 2 to the power of 1.716 plus 1.716 is equal to 5. And now let's use our scientific calculator to verify this. And there we have it. We can see that x is indeed equal to approximately 1.716. Now thanks again for staying tuned with me to the end of this lesson. I hope that this was very informative. If you like this video, please remember to smash that like button, share. And if you would like to see more of these math lessons, you can subscribe to my channel for my latest updates. And until then, I will see you again soon. Thanks again and take care.